Right, so the elevator problem. So we have an elevator starting from here, position A, speeding up to B, then keeping a constant velocity from B to C, and then slowing down to stop at floor position D. And then we will see the downwards motion speeding up from D to C, getting a constant speed from C to B, and then slowing down to stop again at position A, floor A. So what we have is that as it starts from A to B, it speeds up, the velocity is up, the acceleration is up, then the acceleration becomes zero, constant velocity, and then for it to slow down, just because it still goes up, acceleration needs to go down. It needs to slow it down and eventually stop it. Now, going from D to C, it needs to speed up downwards, going from a zero velocity to some downwards velocity. Then it moves with this velocity, constant velocity downwards, and then it has to slow down and stop, meaning the velocity is down, so the acceleration has to oppose, it should be up. So what we actually see is that either it goes up or down. From A to B, the acceleration is up. From B to C, either going up or down, the acceleration is zero, and either going up or down, from C to D, the acceleration is down. So actually the acceleration has the same direction and it's inwards, the figure. So what we see is we have the free body diagram from D to C. This is the free body diagram for what is going on from D to C and from C to D. This is what is going on when it goes from D to C or C to B, and this is what is going on when it goes from A to B or B to A. What we have is that the only forces that are happening on the box in the elevator is the force due to gravity and the normal force that it holds it from falling. So what we see is that, well, no horizontal forces, sum of forces on the x-axis is zero in all cases. In here, the sum of forces on the y-axis is mass times acceleration. We have acceleration, and it's negative. I didn't add the negative sign here, I added it here. I hope it works for you. So if we consider the upwards direction to be positive and the downwards to be negative, what we have is normal minus force due to gravity equals negative ma, because the acceleration is negative, down. Meaning that if I solve for the normal force is gravity minus ma, which means that the normal force in these cases is less than the force due to gravity. So the pressure under the feet, the pressure between the box and the floor is less. By how much? It's less by mass times acceleration. This is what is going on. Now, if I want to draw it, I need to make sure that the normal force is shorter than the force due to gravity to show that it's less. In this case, we have that there's no acceleration, the sum of forces is zero. That means that the normal force should equal the force of gravity, and in my free body diagram, these two lengths should equal. And then the third case, from A to B or B to C, again we have the similar free body diagram. The sum of forces on the y-axis is mass times acceleration. Acceleration is positive now. It goes up. So what I have is normal force minus force of gravity equals mass times acceleration. And what we find is that the normal force is the force due to gravity plus mass times acceleration. So in this case, normal force is more than the force due to gravity by ma. It's more. So I need to make sure that this length is bigger than that. That's how the basic elevator structures work. What happens now if the acceleration is g? What happens if we will see it in the next one.